Section 12.3, Protecting APIs with Spring Security and OAuth2, reactive. Securing reactive Spring Boot applications like order service is similar to what we did for catalog service. Spring Security provides intuitive and consistent abstractions across the two stacks, which makes it easy to move from one stack to the other. In this section, I'll guide you through configuring order service as an OAuth2 resource server, enabling JWT authentication, and defining security policies for the web endpoints. Section 12.3.1, Securing Spring Boot as an OAuth2 resource server. The Spring Boot starter dependency that includes Spring Security and OAuth2 support for resource servers is the same for both imperative and reactive applications. In the order service project, order service, open the build.gradle file and add the new dependency. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 12.16, Adding dependency for Spring Security, OAuth2 resource server.
Next, we'll configure the integration between Spring Security and Keycloak. Configuring the integration between Spring Security and Keycloak. The strategy for integrating Spring Security with Keycloak will be similar to what we did in catalog service. Open the order service project, order service, and update the application.yml file with the following configuration.
Listing 12.17, Configuring order service as an OAuth2 resource server.
The integration between order service and Keycloak is now established. Next, we'll define the necessary security policies to protect the application endpoints. Defining security policies for JWT authentication. For the order service application, we want to enforce the following security policies. All requests should require authentication. The application should be configured as an OAuth2 resource server and use JWT authentication. The flow for handling JWT authentication should be stateless. There are two main differences here from what we did in catalog service. The reactive syntax is slightly different from its imperative counterpart, especially the part for enforcing JWT authentication, stateless. We're not extracting user roles from the access token because the endpoints don't have special requirements depending on user roles. In the order service project, create a security config class in a new com.polarbookshop.orderservice.config package. Then use the DSL provided by server HTTP security to build a security web filter chain configured with the required security policies.
Listing 12.18, Configuring security policies and JWT authentication for order service.
Let's check if this works. First, we need to run the backing services, Polar UI, Keycloak, Redis, RabbitMQ, and PostgreSQL. Open a terminal window, navigate to the folder where you keep your Docker Compose configuration, Polar deployment/Docker, and run the following.
See this code?
Then run Edge service, catalog service, and order service on the JVM./gradle boot run from each project. Finally, open a browser window and go to localhost 9000. Since order service doesn't have particular requirements depending on the user's role, you can log in with either Isabel password, or Bjorn password. Then pick a book from the catalog and submit an order for it. Since you're authenticated, you're allowed to create an order. When you're done, you can visit the orders page to check all the submitted orders. Wait a second. What do you mean, all the submitted orders? I'm glad you asked. At the moment, each person can see the orders submitted by all users. Don't worry, later in the chapter we'll fix that. Before we do, though, we need to discuss how to test the new order service security policies. Stop the running applications, Control-C, and containers, Docker Compose down. The next section will show you how to test security in a reactive application. Section 12.3.2, Testing Auth2 with Spring Security and Test Containers. Testing secured reactive Spring Boot applications is similar to testing imperative applications. Before starting, we need to add new dependencies on Spring Security Test and Test Containers Keycloak. The dependency adding Junit 5 support for test containers is already there. Open the build.gradle file and update it as follows. Remember to refresh and re-import the Gradle dependencies after the new addition.
Listing 12.19, Adding dependencies to test Spring Security and Keycloak.
We can implement full integration tests using Spring Boot Test and Test Containers Keycloak. Since the setup is the same as for catalog service, I won't cover those tests here, but you can find them in the repository accompanying the book, Chapter 12/12n/order-service/src/test. Make sure you update those integration tests, or the application build will fail. In this section, we'll test the web slice of a reactive application when the endpoints are secured, much like we did for catalog service. Testing secured REST controllers with WebFlux Test and Spring Security. We have already written auto tests in Order Controller WebFlux Tests for the web slice using WebFlux Test. Let's see now how to update them to take security into account. As part of the OAuth2 access token validation, Spring Security relies on the public keys provided by Keycloak to verify the JWT signature. Internally, the framework configures a reactive JWT decoder bean to decode and verify a JWT using those keys. In the context of a web slice test, we can provide a mock reactive JWT decoder bean so that Spring Security skips the interaction with Keycloak, which will be validated by full integration tests.
Listing 12.20, verifying security policies at the web layer with slice tests.
Open a terminal window, navigate to the Order Service root folder, and run the newly added tests as follows.
See this code?
As always, you can find more test examples in the source code repository accompanying this book, Chapter 12/12n/order-service,